Hello everyone, myself Rion, joined by Prakash Thapa and Rohan Atraye. We are a student of first semester of Department of Mechanical Engineering in Barak Valley Engineering College. In this video, we will be presenting our project titled Eco-Friendly Printing Solutions, where we focus on redesigning modern printers to make them more sustainable, cost-efficient, and user-friendly. Before we go any deeper, let's think about something very common. Almost all of us have used a printer at home, in college, or at an office. And we all know one thing, traditional printers comes with many problems. So the first one is high cartridge cost. In many cases, buying new ink cartridges costs more than buying an entirely new printer. Users feel cheated because printing becomes an ongoing expense, not a one-time purchase. The second major problem is environmental impact. Plastic cartridges often end up in landfills. They are non-biodegradable and more than 1.3 billion cartridges are thrown away annually worldwide. This contributes heavily to pollution and plastic waste. The third one will be the ink drying and clogging. If a user doesn't print regularly, the ink inside the cartridge dries up and leads to clogged printing heads, sticky output, and frequent maintenance. The fourth issue is maintenance complexity. Printers have several fragile internal components. A small issue usually leads to expensive repairs, making users frustrated and dependent on technicians. Because of all these problems together, the world needs printing technology that is cost efficient, environmentally friendly, mechanically simple, and more user friendly. This is what led us towards thinking differently. Our objective was to create a solution that reduces printing cost, minimizes environmental impact, simplifies the internal mechanism, and makes the printing easier for everyone. With these goals in mind, we started exploring new ideas, and this led us to the foundation of our solution. Now, I would like to hand over to my friend Prakash, who will explain the innovation we developed.
Once we fully understood the problems, we brainstormed on how to redesign the entire printing mechanism. This led us to create a concept we called the next generation eco printer. This printer replaces traditional ink cartridges with solid pigment blocks stored inside reusable aluminum cartridges. The core components include solid pigment blocks instead of liquid ink, reusable aluminum cartridges lasting up to 2 years, spring-loaded feed mechanism for consistent pigment flow, precise heating chamber to melt only the pigment surface, roller-based transfer system to apply pigment onto paper, anti-clog cleaning brush. This design solves all major issues. No drying or clogging, very low waste, lesser mechanical parts, lower long-term cost, higher sustainability. This vision was shaped by design thinking. We followed the design thinking approach because it is human-centered and help us to understand real user problems before designing any solution. We are having empathy phase, and in this phase our main objective was to collect genuine user experiences. We interacted with different groups who regularly use printers. First were students. For students shared that their ink runs out very quickly and buying new cartridges becomes a major expense. They often avoid printing notes or project because it's simply too costly. Second were office workers. Office employees told us that printers suddenly stop working, especially due to ink drying and nozzle clogging. This slows down their work and causes delays in submitting documents. Thirds were the teachers. Teachers highlighted that refilling ink tanks is messy and time consuming. During busy schedules, dealing with ink spills or faulty refills becomes a major inconvenience. Fourth and the most important ones were print shop owners. Print shop owners explained that they rely heavily on printers every day, and frequent servicing directly affects their business. Maintenance costs are high, and many downtime means loss of income. To understand the problem even accurately, we did not rely on interviews. We also read hundreds of online reviews to see what users complain about the most, visited photocopy and print shops to observe how printers behave in real working conditions, tested different types of printers ourselves, including inkjet, laser, and tank printers, to experience issues like clogging, streaks, and drying ink firsthand. By combining all these observations, we developed a strong understanding of the actual challenges users face. These insights help us clearly define what our new printer must solve, making the empathy phase one of the most important part of our design thinking process. After gathering all the feedback during the empathy phase, we move to the define phase, where we analyze the information and identify the core issues users face. Even though different groups had different problems, they all pointed to the same root causes, that printing is expensive, difficult to maintain, and environmentally wasteful. By grouping all these insights, we framed one clear problem statement, that user needs an affordable, low maintenance, and eco-friendly printer that does not clog, is easy to refill, and reduces long-term cost. This statement became our guiding direction. It allowed us to stay focused on solving the real challenges instead of getting distracted by unnecessary features. Every design decision we made, from choosing solid pigments to using a reusable cartridge, was aligned with this defined need. In short, the defined phase transformed scattered user feedback into clear, actionable goal for innovation. During the ideation stage, we generated more than 20 possible concepts, that cartridge-less systems, powered-based printers, solar-powered designs, and more. But the solid pigment system emerged as the most practical and impactful idea. Our prototype included a spring-based pigment feeder, a heating chamber, an anti-clog sweeper, reusable aluminum cartridges. Initial user feedback was very positive, especially because the printer never clogged and was easy to refill. Now my friend Rohan Atraye will talk about our final refined design and the impact it creates.
Now that we have tested, upgraded and polished our model, let me introduce to the final version of our EcoPrinter. And that is where things get exciting. Here's what makes our design stand out. A super durable aluminum cartridge that can last up to 2 years has been used. A solid pigment block that never dry or clog. A smooth spring-based feeder for consistent printing has been used in our design, and also an automatic anti-clog process that keeps everything clean on its own has been used. And our design has 30% fewer moving parts, making the whole mechanism stronger, smarter, and easier to maintain. In short, this printer is designed for real users, which is simple, clean, and ultra reliable. Now let me walk you through the exciting working mechanism. It's simple but brilliantly effective. Firstly, we load a solid pigment block into the metal cartridge, and then a spring pushes it forward with perfect pressure. Then after, only the top surface melts inside a controlled heating chamber. No overflow, no mess. Then after, rollers instantly transfer this melted pigment onto the paper, and then those little anti-clog brushes keeps the system fresh and dust-free every single time. This means no drying, no clogging, no headaches, just smooth and consistent printing. Our eco-printer creates a positive impact in three major areas: environmental, mechanical, and economic. Let's talk about environmental impact. Our design removes the biggest source of printing waste, plastic cartridges. By using a reusable aluminum cartridge and solid pigment block, we eliminate the need to throw away plastic after every few prints. The pigment we use are biodegradable, which means they break down safely without harming the nature. Because there are fewer manufacturing and transport cycles, the overall carbon footprints per page becomes much lower. So the printer contributes to clean, greener, and more sustainable printing. Let's talk about mechanical or technical impact. Our system avoids the most common printer issue, that is dried ink and blocked nozzles. Since the pigment is solid, it never dies or clogs, making the printing process more reliable. The mechanical design is much simple with fewer moving parts, around 30% fewer than a traditional printer. This means fewer breakdowns, easier maintenance, and better long-term durability. Now let's talk about economic impact. Economically, the eco printer is much cheaper to operate. User can print at up to 60% lower cost than traditional printers because solid pigment blocks are far more affordable than ink cartridges. Refills are extremely cheap and the reusable cartridges reduces recurring expenses. This makes the printer ideal for school, offices, government department and home users who want to quality printing at lower cost. At the end, our project proves one powerful message. When mechanical engineering meets design thinking, we can transform everyday problem into smart and sustainable solutions. With our solid pigment technology and reusable cartridges, we successfully solved issues like clogging, waste, and high printing cost all at once. By this, we conclude our presentation here. Thank you for listening. We would be happy to answer you in the comment section.